Welcome back. And now let's go a bit deeper into the law of free fall and where that number 9.8 actually comes from. For that, we need to look at Newton's universal law of gravitation, which we will come to in a couple weeks. But basically, what Newton said is that the force and gravity in the universe is equal to some big, strange constant called g times the mass of the two objects. Let's call this the mass of the object that's falling and the mass of the Earth. So big M for mass of the Earth, small m for the mass of the little object, divided by the radius of the Earth squared. So that's Newton's universal law of gravitation. Now, if we look back and combine that with what we derived last time, where we said, hey, the acceleration is equal to the force divided by the inertia, what we find is that the inertia and the mass of the small object cancel out. So I've got big G, mass of the small object that's falling, mass of the Earth, divided by the radius of the Earth squared, divided by the inertia. And what we find is that the inertia of the object cancels out with the gravitational attraction of the object, leaving us with Newton's universal gravitation constant, the mass of the Earth divided by the radius of the Earth squared. And if we plug those numbers in, and you can look those numbers up on your own, Newton's universal gravitational constant, the mass of the Earth, and the radius of the Earth squared, and if you plug all those numbers in, you will get 9.8 meters per second squared. And you can use Google or any good textbook to find the mass of the Earth, the radius of the Earth, and Newton's universal gravitational constant.